Okay, so in the last video, these Altech smart relays, we had a simple motor start circuit. Now let's say that we wanted to have two motors and we wanted them to run one at a time, selected as a main unit or a run unit and then a standby unit. And you wanted it to auto fail over to the other if for some reason the primary failed. Can we do all that with this one brick unit here with just 8 inputs and 4 outputs? Well, what I like to do when I try to write a program like this is take all my label all my inputs and outputs and write an objective of what I'm trying to accomplish here. So I did that with this. Let me show you what I wrote. It's relatively simple outline here. When I write a program that will control a two-motor system, allowing one motor to be selected as primary and the other to be a backup via selector switch. So we need a switch that will tell us which motor we want on primary and which one we want to be on standby or backup. And then we want the program to have a start-stop circuit like we had before with an e-stop. So we still want to have that in there. So we can push the start button to start whatever is selected as primary and then be able to stop it and e-stop it if we had to. We want the program to have a run light telling us that a motor's in run mode and running, should be running. Program should have a fault light that stays on until the fault is acknowledged with a reset button. So in the last program, we had a fault light, but what might happen in that case is, say your overload trips out or whatever other fault we were to put in, sometimes they go out and then they reset themselves. For instance, overloads can be set to auto reset. Now, you may not know what the fault was. Then you don't know you have a fault. You just know that your primary isn't running anymore and your backup is. So we want the fault light to stay on and until we acknowledge it with a reset button. So we're going to need an additional button for that. And the program should auto fail over, like we said, to the standby motor. So we want to run consistently, let's say 24/7. We don't want a pump to shut off. So we have a primary and a backup in case we have a problem with the first one. It auto fails over to the second. So need to make sure we have enough inputs. I had to be a little creative with some of this stuff when I wrote the program because we have, if we're just using one unit without expansion modules, we have 8 inputs and only 4 outputs here. So input 1 I have down as the start PB, input 2 stop PB. PB stands for push button, but it didn't clarify that. Input 3 is the e-stop. Input 4 is going to be the overload for motor A. Input 5 is going to be the overload for motor B. And then input 6 is motor A run mode. And input 7 is reset fault. Now I could have an additional motor B run mode. I'm trying to eliminate using all the inputs because I want to add something else here. And what we can do here with motor A, you'll see we select motor A as run mode, then automatically motor B is in standby mode. If run mode A is not in run mode, then B becomes the one in run mode and A becomes the standby mode. So I can eliminate wiring and we can eliminate extra inputs here. And then on the output side, of course, we need to be able to run motor A. We need to be able to turn on that motor starter. Motor B, we need to be able to turn on that motor starter. We're going to need an output to give us an indicator light that we're in run mode. And we're going to need a fault indicator light. So we're going to need something to tell us that we're in fault mode. So I have all this kind of outlined. And then when I write the program, I'm of course just going to take this and just dump it right into my inputs to start with. That way they're all labeled. And I can just drag and drop. And then same thing on these outputs. So we'll go into the program now. And we'll start labeling these. This is going to be the start PB, stop PB, E stop, and I believe I had overload A, overload B, and then run and reset. So okay, so we have all those. Now we can go to our outputs. Okay, so got everything written here. Relatively simple. Like I said, there's not a lot to it. So I'll put the E stop first. Just going to drag that over and drop it. I'm going to make that a normally closed contact. So I just right click on that, dropped it down, made it a normally closed contact. And then the next here, I want to put a start. Put that there. That's going to be normally open. Some of this stuff can be manipulated as you need to. You may decide that you want to use a normally closed or normally open for some of this stuff. That's fine. This is just how I decided to do it. We're going to put the stop in here. This is similar to how we did it last time. What I am going to change here is to save outputs. I'm going to use one of these auxiliary contacts here. So this is going to be an M contact. And I'm going to call that a start relay. If this is internal, I'm using this to give me kind of a safety circuit here. I want to drop this in here. And then like we did before, I'm going to take that and I'm going to seal this in. And I'm not going to use the term latch this in because we're going to do something like that later, and it's actually called a latch on latch. This is going to be a seal in circuit. Very similar to what I'm doing here. Okay. So that's your basic start stop, just to give us basically a safety relay here. Maybe I should have called that a safety relay. It's a start relay. And we're going to use that as permissive for running the other motors. So we can add a comment here like we did last time. If E stop is pushed, and stop is not pushed, and start is pushed, turn on this start relay. I like to put comments in there to tell me what what I'm trying to do. You might look at that and say, well, yeah, I can see what we're doing here, but this this helps other people as well. What are we trying to accomplish here? Maybe they want to take something out here and say, oh, well, I can't do that because there's a reason we have that in there. So we're going to use that as a permissive for each motor. So I'm going to do is create a motor A and a motor B permissive in these auxiliary contacts, the same as that start relay. So let's call this motor A permissive, and let's call this motor B permissive. And the next line here, I'm just going to use as a permissive string. Okay. And then I'm going to throw in start relay to the same start relay in the first part of it. So you can't do that. You can't run this motor without that. And I'm going to put an overload in here for now. I'm going to say, okay, if that overload's true, we can't run this. Put that right here. But I'm going to make that anomaly closed. All right. I think I'm going to add something here a little later, but I'm not ready to do that. So we'll come back to that line. Now, let's use the motor A permissive to run motor A. We're going to take this for the next line here. Motor A permissive. So we can't run motor A without that, right? And we're going to throw that in right here. Okay. So you got to have motor A permissive to come in. And then we're going to use run mode for motor A, which we decided was input 6. We're going to put that right here. So we have to select motor A in run mode here. And then we're going to turn on motor A output. For A output. But I want to add, let's say motor B kicks out. I want to seal this in to run all the time using the auxiliary contact here on motor A. And then I want it to I'm going to seal that in. I'm also going to add, if we were to drop out motor A, I'm sorry, motor B, we drop out motor B, we want motor A to kick on. So let's say that this one isn't selected. It's not selected on this input 6, but motor B is selected and it drops out. I want that to pick this one up as a failover. So if we get a fault from motor B, when we get down to motor B, we want it to be able to parallel this this selection bit here. So motor A's got a permissive, let's say, everything's okay with that. It's just not it's not selected. The start relay is okay, the overload's not tripped, but motor B fails. So this circuit hasn't been turned off to tell us to stop anything, but motor B fails. Then we want motor A to kick on. We want that overload to automatically kick on motor A. Let's go down here and do the same thing we did here for motor A, use that for motor B. So of course, we're going to need our start relay. Then we're going to need our overload. This one, of course, is going to be for B. Put that back here. And then we're going to need our output. This is just for the motor B permissive. Throw that in there. Now the next line is going to be similar to this line. We're going to do the same thing here. We're just going to do motor B. So go back into our outputs. Put motor B down here. And then because we don't have a selector here, this is this should say motor A run mode. Okay. We're going to use this same input down here, but it's going to be the opposite state. So if we're selected for motor A here in run mode, then motor B is going to automatically be in standby mode. If we were to select this motor B, flip it over off of motor A, it will automatically close this. And when we select it as motor A, it will actually open that and it won't allow us to select motor B. So it's automatically going to be in standby mode with that one input. Then we're going to go back in here to throw the start relay. Not the start relay, but the B permissive relay. In there. That's an internal relay. So we have that start relay, which is our internal relay, and the overload's not overload also has to be normally closed. If that overload's not tripped, then we'll have motor B permissive. Motor B permissive will close, and motor A is selected, that will be open. But if motor A is not selected, then B will be selected, and it will bring in the motor B contact here. And now we're going to seal that in just the same as we did before with motor A with the auxiliary. It's not an auxiliary contact. We're going to actually use an auxiliary contact on the internal coil. So in the last program, we had actually used a field contact on the starter. In this case, we're going to use the auxiliary contact of this coil. So we're going to take Q, throw it in there, parallel that. Okay. And then, of course, we do the same thing down here as we did here, but with motor A's overloads. So we'll go into the overloads. Put that there. There. And the idea there again is This will automatically pick up motor B if the overload trips on motor A, and motor A is normally running, but we're selected there. That'll parallel this selection switch here. Motor B should have its permissive as long as its overload's not tripped and the start relay is in. So it should automatically pick up. Okay, so that whole circuit should work correctly, but we don't have a running light, a fault indicator, or a fault reset yet. So let's go ahead and throw in a run indicator, and all we're going to do is take both of these coils in parallel. We don't have a whole lot of options, so we'll throw a run coil here, and then we'll take and say motor A output is on. Okay, let's say motor B output is on. Either motor is on. We're just going to parallel those two. So if either one's on, the run mode's going to come on. I'm going to assume that that's a light. I suppose you could have a siren or something depending on what kind of application you have. And this is going to be permissive for motor B. Permissive for motor A to start. And this is going to be the selection and failover. So let's see, motor A selected and run. So we're selected and it's running. And this is the same for motor B. Okay. Now we're going to add our fault indicator. So let's put a fault indicator here. And what I want to do with the fault indicators, I want to change this to what they call bistable set and reset. Now, some programs, some manufacturers will call this a latch on latch. So you have to turn it on, it stays on pretty much indefinitely until you hit something to reset that. So set reset is about the same thing. But the catch here is we need that fault light to come on. And I think we're going to parallel the faults. So you have either fault. Not really ideal, but it will work. So we'll fault for A. The overloads, we're just going to parallel those like we did the starters for the run. There. So that's going to set the fault. So we're going to set the fault if either overload trips until it is reset or acknowledged, okay? Now, what we want to do though is throw in an input here. There's going to be a push button out there to reset this. And then we're going to use the same output, okay, for the fault indicator right here, but we're going to write this as a reset, okay? So reset fault. You can have that stay illuminated. You know, you got a fault, you failed over in the middle of the night, you come in, why is this one running? At that point, your automatic overload had reset itself and you don't know what's going on, but you look over, okay, my fault indicator is illuminated. I had set A as the primary, but A isn't running anymore, B is running. So before you reset it, you say, well, I must have lost my overload sometime last night. You know, it's just a way to know what happened, trace it out. You could use that for a trap, for like a fault trap. You could do a set reset. You could run each output out to an individual fault light telling, you know, like an enunciator panel telling everybody what had faulted if you lost water to a compressor or air pressure. Okay, one additional thing we need to do here is add an interlock, electrical interlock for the motor A permissive and the motor B permissive. We don't want them to be running at the same time. So if motor A is running, we don't want motor B to be able to run, so we don't have our start permissive. Now, if we drop out, in that case, it should be okay. So let's take this, throw it in front of motor B permissive right here, and we're going to go normally closed. In that case, motor A is not on. That allows motor B to come on. And we're going to do the same thing with motor A on the permissive string and making it normally closed as well. And that will prevent anything from running when it's not supposed to be running. Now let's try simulating this with the PC. Okay, so we're going to start up here with the start PB. We're going to drop it right out, make sure that that works. And then, of course, we're going to try to push the stop button to make sure that works. And, of course, it dropped out the start relay, which drops everything out. So we'll go ahead and put that back into play. Now, motor B is running because we don't have motor A selected. So we hit start. Motor B was selected to run in primary because it was not selected as motor A. And we had our permissive string. We don't have an overload tripped. Motor A was not running, and the start relay was closed. So we see I have a run indicator. Now let's fault motor B kicks here. Let's trigger this, and then automatically let's trigger it and reset it. Basically, we're not going to reset the fault light. We're just going to trigger it and then call it an auto reset. Let's try that. Okay, so now Q4 is on. Say Q4 is on. It's telling us that we have a fault. We did not reset it. We did not hit our reset light. But we have a motor running. But you notice it's motor A. Motor A isn't running. Why? Because we tripped the overload. And when we did that, you see we're not selected to run motor A, but the overload pulled it in, and then that sealed us in. Motor B dropped out because it lost its permissive. The overload, even though we reset that overload, it lost the seal circuit and it lost its permissive on the permissive string, so therefore it dropped it out. Now let's reset our fault. Now Q4 went off, you see. Motor A is still running. Motor B is not. Even though we're not selected there. Reset it. Motor A is still running along, chugging along fine. We do have a motor B overload is reset. And the start relay is in. But because motor A was already running, we can't select it. So in order to get it back to normal mode, what we'd have to do is do a start stop. So we would just have to hit this and then push the start button and motor B will pick back up. That's the extent of that. So we're going to get a little more advanced on the next video. We're going to add some analog stuff. I think I'm going to use this existing routine and we'll just throw in some analog sensors so that it would run, stop. We'll elaborate on that on the next video. So until next time. Sometime last night. This is the way to know what happened, trace it out. You could use that for a